6.8.7 is called writing and graphing inequalities. We've seen inequalities a little bit, like not necessarily an inequality, but we've seen inequality signs and symbols, right, where we are comparing values, which was greater, which was less. So this is going to go a little bit more in depth on that. To start with the definition of an inequality. Okay, an inequality is a mathematical sentence comparing expressions. So it says one is bigger than the other, one is smaller than the other. It compares the values with inequality symbols. So we use 4 symbols for inequality. These are them. We've got less than, greater than, and then the last 2 are less than or equal to. So the little line underneath is like half an equal sign, and that means less than or equal to. And the other one means greater than or equal to. So because it means or equal to. Because if we say that something is greater than or equal to 3, it doesn't just mean any number greater than 3. It also means 3 is part of that solution or equal to. Okay? So sometimes we are saying it's only things that are bigger than or less than. And sometimes we're including that number as part of our solution. So the inequality symbol shows that. Okay? With the little half an equal sign underneath. That means or equal to. Now, when we write inequalities or when we're doing word problems that have inequalities, these signs can be interpreted or translated with words. So part of your job in this lesson will be translating words to inequalities. The less than sign can be represented by the words is less than or is fewer than. Okay, so if you see those words, you're using the less than symbol. The greater than symbol, as would make sense, is represented by the words is greater than or is more than. Those words mean you plug in that greater than sign. All right, the next sign is less than or equal to. So obviously the words is less than or equal to will clue us in that we need to use that symbol. Now, the next one, it makes sense, but you have to think about it a little bit longer because it's not quite as straightforward as the first set of words. The less than or equal to sign can also be represented by is at most. So if you say, or if I say to you, I'm going to give you at most $10. That means I'm giving you less than or equal to $10. I'm giving you at most or no more than. Okay? That means I'm not doing any higher than $10. I'm going to give you at most or no more than. So less than or equal to. Right? So it's kind of opposite, but if you think about it, it makes sense. All right. And finally, the greater than or equal to sign can be represented by the words is greater than or equal to. And then, yes, so then we'll have our other 2 that kind of at first don't make sense, but we have to think about it. If I say, I want you to pay me at least $15 for this job, then I'm expecting $15 or more. Yeah, $15 or more, because I want at least 15 or more. Okay, so is at least or is no less than. Those mean greater than or equal to. Example is taking words and changing them into mathematical symbols and numbers. Okay? For example, a number C is less than 4. So we're going to start with this, C, and we're comparing it to -4. Our inequality symbol is less than, means we will use the less than symbol. And then the number -4 means we'll use -4. So that's all we're doing is taking the words and translating them into an inequality. Another one. A number k plus 5 is greater than or equal to 8. So we start with a number k plus 5. How would I write that? Just k plus 5. Good. K plus 5. And then our inequality is greater than or equal to, which means we'll use that sign greater than or equal to. That has the little half and equal sign on the bottom. And then it's going to be greater than or equal to the number 8. Bless you. Let's do one more. 4 times the number p is at most 16. So let's start here. 4 times a number p. How can I write that? How can I write that, Luke?
4 times
P. Yeah, can I write that more simply than 4 times p?
4p.
Yes, 4p. Okay, these variables are just representing numbers. So 4 times p means 4p. Okay, our inequality sign is at most. What did we say? Which inequality symbol represents that, Colin?
The one this with the line on.
Yes, look above it. What is it? What's the first? What's the first set of words? Yes, or
It looks like this.
less than or
Fewer.
equal to. Less than or equal to. Okay, and then it's going to be less than or equal to what number? 16. Remember, is at most means less than or equal to. So I need you to become familiar with naming these signs. Okay, you should be able to look at it and say it means less than or it means greater than. Less than or equal to or greater than or equal to. Not just making symbols with your hands. I want you to be able to say what it is. Okay, so we'll practice that. All right. The solution to an inequality is any value that makes it true. A solution to an inequality is any value that makes an inequality true. There are multiple solutions to inequalities. If my inequality is x is less than 10, what numbers would be solutions to x is less than 10? What could x equal? 9. Good. 8, 7, -10, right? There's tons of numbers that make that true. All right, so inequalities have many solutions. To check if a number is a solution to an inequality. So you'll be asked is, like if your inequality is x is less than 10, and you'll be asked is -7 a solution? What you do is you would plug in the variable. So instead of x, we'd put -7 less than 10, and we'd ask ourselves, is that true? And looking at our number line, -10 would be up positive, greater than 0. -7 would be way less than 0. And so we could say, yes, that is true. -7 is less than 10. So it is a solution because it makes the inequality true. Okay, if it makes a true statement, it's a solution. If it makes a false statement, it is not a solution. So we'll do some practice with this. But this is our rule of thumb. When you simplify, if it's a true statement, then it's a solution. If it's not a true statement, it's not a solution. Here's how it's going to look on your homework. So I wrote these exactly how they'll look on your homework so that when you see it, it's not going to be like, what the heck?
What in the...
All right, here's what it's saying. This is our inequality, and it's asking us, is this a solution? So if x is 8, is that a solution to the inequality? Here's what we're going to do. we're going to plug in 8 for x in the inequality. So we'll get x as 8 plus 1 greater than 7. And then we simplify. 8 plus 1 is 9. Greater than 7. Shh. The last step is we ask ourselves, is this true? Is 9 greater than 7? Yes. That means that x equals 8. Yes. Is a solution to this inequality.
Yes.
Let's do another one. All right, here's our inequality. 7y less than 27 when y equals 4. So we're going to take this 4 and plug it in. So we'll get 7 times 4. So plug in 4 for y less than 27. And then we simplify. 7 times 4 is 28.
Which is greater.
Is this a true statement? No.
Not a solution.
That means when y is 4, that is not a solution to this inequality. When we plug it in and simplify, it's not correct. So 4 is not part of that solution set. Okay, one more. Try this one on your own. Try this one in your notes. 5 is greater than or equal to x over 3 when x is 15. Hudson, what do you say? So is it a solution or not?
Yeah.
Yes. So watch what happens, you guys. Shh. When you plug it in, you get this. 5 is greater than or equal to 5. The inequality sign is super important because one of our options is or equal to. So is 5 greater than or equal to 5? Yeah, it's equal to. So that is true, meaning this is yes, a solution. The second part of this is going to be using a number line to show solution sets of inequality statements. So we'll use a number line to graph and to show all the solutions to an inequality statement. Okay? Let's look at what this looks like. Now, I'm going to show you the rules, and then we'll do examples, and then it's going to make a lot of sense. To graph, we will put an open circle if the inequality says greater than or less than. The open circle at the number that we're starting at means we're not including that number in our set. So like if it was greater than 5, we're not including 5 because it's not equal to 5 too. So we put the open circle for just greater than or less than. We put a closed circle or a filled in circle for the or equal to's. So greater than or equal to and less than or equal to. And then the last part is we'll put an arrow pointing in the direction of all the solutions. So if it's greater than that number, we'll draw an arrow going to the right on our number line, getting all the numbers that are greater than. If it's less than that number, we'll put an arrow going to the left, going to all the numbers that are less than, getting smaller, right, away from 0. Here's our example of this. It says graph G is greater than 2. So we're going to use a number line, and we're going to graph this solution on a number line. So start with your number line, and then you need to label the points. So let's go ahead and just label, like, make this 0, 1, 2, 3. You don't have to necessarily label all the points, but just make sure you have a couple points for reference. This is G is greater than 2. So we're going to start at 2, and we're going to have what kind of a circle?
Semicircle?
What did I say? Look at your notes.
Full. No.
No, it's literally written there.
It's
Elin, what did I say? What kind of circle for just greater than?
an open circle.
Thank you. An open circle. I just knew you had the notes written down, so I knew you could find it. Good. An open circle. That means it looks like this. It is not filled in because it's not equal to 2. We can't include 2 in this solution set, right? And if we're graphing the numbers greater than 2, we draw an arrow going to the right, indicating every number greater than 2 is part of this solution. Going on forever down that number line. Okay? Let's do another one. Oops, I didn't realize I wrote that. All right, let's do A is less than 4. Did I write the numbers on here? No. Okay, start by, you need to write your numbers on your number line. So 1, 0, 1, 2, 3, 4, 5. Make sure you at least have the number and 1 on either side of the one that you're going to graph. So like we want to make sure we have 4 and then a number on either side of 4. All right, what kind of a circle should I put at 4? Liam? An open circle because it's not equal to 4, but it's going to start as close to 4 as you could get, right? Okay, and then less than 4, which way will my arrow go, Hudson? To the left. Okay, meaning anything that comes to the left of 4 on the number line is less than 4, so that's part of this solution set. How about this guy? F is, excuse me, less than or equal to 7. I'm going to move my 0 here because I want to make sure I can get to 7. 3, 4, 5, 6, 7. Pretty good. All right, what kind of a circle should I put at 7? Modibo? No, what kind? Drew? Closed circle. So this means we'll draw the circle, and instead of leaving it open, we fill it in. That means that it could equal 7 too, because it says less than or equal to 7. So we put a closed circle or a filled in circle. And then which way should my arrow go if F is less than 7? Kennedy? To the left. To all the numbers less than 7. Any of those numbers would make this a true inequality statement. Okay? All right, let's see. Let's see what else we got here. Oh, this is important. When the number comes first, so on this slide, we always had A, or the variable, the inequality, and then the number. Sometimes you will see it like this, where the number comes first. I always rearrange to make sure that my variable is first because it makes more sense to me to graph. The key is that you always need to make sure that the mouth of your inequality stays open toward the same thing that it was open toward in the first place. So if we rearrange this and put our P first, make sure that your inequality sign still opens toward the P, and then put the -3 on the other side. It just makes it easier to make sure that your graph is going in the right direction and that your arrow points to the right values. Okay? Oops, sorry. So if we were going to sketch this now on a number line, we'd have 0, 1, 2, 3, 4. So -3. 1, 2, 3, 4. Something like this. What kind of circle would I put at -3? A full closed circle. A closed circle is usually what I say. Closed circle. Okay, and then which way would my arrow be going?
Right.
Yes, to the right. Everything greater than or equal to -3 is part of the solution set. Okay, so when you see the number first, it can be confusing. I always rewrite it with the variable first so that you get your graph right. All right, let's do one little real life problem. Okay, a NASA solar probe can withstand temperatures up to and including 2,600 degrees Fahrenheit. Write and graph an inequality representing this. All right, so let's call our variable x. Can we write an inequality saying temperatures up to and including 2,600 degrees? How would we write that as an inequality? X is, what do you think, Liam?
The More than equal.
More greater than or equal to 2600? Less than or equal to, because it goes from everything up to 2600 and including 2600. So it's less than or equal to, but not more than, right? So it's actually going to be a less than or equal to 2600. That's our inequality. To graph this, we'd have our number line. This is not super straight. And maybe we go by like hundreds. Okay, so let's start at like 2400, 2500, something like this. Right? It doesn't have to go by ones. Your number line can go by different denominations, especially when you have really big numbers like this. To graph, what should I put at 2600? Hudson? Good. Closed circle. And then which way should my arrow go? Go ahead. To the left. Everything less than 2600. It can withstand temperatures for anything less than 2600. And can it be at 2600? Yes. Then once it gets higher than 2600, it probably has problems, right? It's getting too hot. But it can be 2600 or anything that's less than that. All right?